So, good afternoon, everybody. Thanks, first of all, thanks the organizing committee for giving me the chance to present you some of the work that we have been doing at Sparos. For those of you who don't know us, Sparos and Research, we are private companies located in Portugal, but I will show you some data on salmon, so it's a little bit cultivated in the hottest part of Europe at this moment. So, and I will start by presenting you, or what I would like to show you a little bit, this new buzzword that we hear in nutrition, which is precision nutrition. Like before, we were not precise. That's not the case. We know a lot about nutrition, but we are at the stage where we can see still opportunities to optimize, so to fine-tune some of the knowledge that we have been generating over the years. And so, what we see now is that when we are formulating feeds or having nutritional concepts, we have to put a high focus on the production performance. It's not longer just feed costs, raw materials and all that. We have to concentrate ourselves in doing the best we can with the resources that we have. Because we have been hearing a lot about new ingredients, it's true, we need them to grow, but we also need to do better with the existing resources. And so one key concept that it's more or less clear is that to maximize the performance and the guarantee that we have reliable performance data, the optimal supply of digestible nutrients should ideally be constant. It means the blue line is the most relevant for the animal. The red line, which would be, let's say, the crude protein level in the feed, is not that relevant. It's the blue line that makes the difference. And so, nutrient digestibility of raw materials, it's routinely measured by the feed manufacturers or even by the feed suppliers themselves when they want to generate their own data. And so this is done. This is classic. We run several trials per year on this topic. But our question, and what I would like to a little bit to discuss and present to you, is within the classical digestibility trial, are we taking the most information we can, or is there still room for making it? And of course, the answer is, I believe, or we believe, that there is room for it. And so I will go fast on this part, because this is nothing very new, but this is, we run one very classical digestibility trial of raw materials. I don't know if the laser, I don't see it. It's working? No? Okay. So, and in principle, we did it as most people do, which is we have a reference diet, which is very high in fish meal, wheat starch, some additives, including, of course, a marker for digestibility, which is in our case the yttrium oxide, and the fish oil. And then we tested the various raw materials which were incorporated at 30%, and we make slight adjustments on the reference formula by adjusting the fish meal that was used in the reference diet to guarantee isonitrogenous conditions, also adjusting the fish oil to guarantee that the crude fat levels are also equivalent, and then we make small adjustments on the wheat starch to guarantee that we have a formula with 100% with all. And then we tested a vast array of raw materials. We have then the reference diet, then we tested the lower quality fish meal and krill meal as marine protein sources, some land-based animal proteins, poultry meal, blood meal, feather meal, and an insect meal from tenebrio in this case, some single-cell proteins in which we tested its Corynebacterium glutamicum biomass, which is a byproduct from the amino acid production, the Micrococcus capsulatus biomass, and spirulina, microalgae, and then some vegetable protein concentrates, very classical, soy protein concentrate, wheat gluten, corn gluten, pea protein concentrate, and some more coarse vegetable ingredients that in some cases are not very present in salmon feeds, like the soybean meal, and this is even a soybean meal 44. It means that is only solvent extracted. It still has the hull, so it's relatively aggressive to the fish. So we run the trial at our facilities in Portugal with the Atlantic salmon of 170 grams average weight in a RAS system at a temperature of around 13.7 degrees. We did an adaptation period of 34 days, then the feces were collected by stripping, and of course we did the classical yttrium and nutrient analysis for the apparent digestibility coefficients, but we also collect feces for measuring other markers that I will come, and the intestine for the next stage. So here again, the values are within the normal range. For those of you who are more familiar, some can go up and down a little bit on these digestibility studies, but let's say that nothing very shocking, except that, for instance, I have to mention, which is the blood meal, which showed a very low protein digestibility, but we more or less attributed also to the fact that there was a very, very low feed intake. The palatability was an issue with this diet, because in this case, we used the 30% level of incorporation, which for some ingredients, it's a bit too high. We were not able to make it. Also, the energy digestibility. So the key message here is that up to now, this is the classical approach. This is, for those of you who are on the nutrition field, this is what we do on a very routine basis. So now, can we do more? And as I said, we believe we can. So with the same feces that we collect, so nothing that required any changes, we started and we measured. We have been measuring this for a long time on other species, but we tried it also in the salmon trial. So we start measuring a non-invasive fecal inflammatory markers. Although we cannot make a direct and straightforward association to the raw material, we have to accept that although measured on feces from complete feeds, we consider that the major nutritional change that existed among the various feeds was the test raw material. So what we are seeing, in our opinion, of course, is debatable. It can be an indicator on the effect of the raw material itself. And we measured one of the first markers was the fecal calprotectin, which is a protein that is released by the intestinal activated neutrophiles. It's a sort of cells, immune cells that are mobilized in certain situations at the intestine level at the epithelium. And so, in general terms, higher fecal calprotectin is associated to intestinal inflammation. You can see this is done in humans, of course, also in dogs, in several other animals, in which, of course, they cannot go and collect samples in a much invasive way. I will come to the, let's say, limitations of this type of metabolites. But what we can see here is that blood meal, one of the single-cell proteins, soybean meal and sunflower meal, showed, the orange bars showed some elevated levels of calprotectin. This does not, I have to, the second marker that we measured was the mucins that we can find also in the feces. And you can see that, again, you have in the light green is the reference diet. So for us, something with around 50% fish meal would be a sort of a golden standard. Maybe it's not also true, but it was considered as if the intestine has to be in good condition, it should be with a high fish meal diet. And then, again, you see that blood meal, the hydrolyzed feather meal, the sunflower meal showed high elevated or high levels of mucins. So, and mucins, for those of you who are also less familiar, are glycoproteins that are secreted by the goblet cells that we have in the intestine and the tissues, of course, and that are essential for mucosal defense. So, again, generally, higher fecal mucins are associated to an intestinal irritation or inflammation. So, with these two sets of markers that I have here, we are not saying stop using these ingredients because they are at 30% incorporation. The diets were not formulated to be fully complete. It's just to give you a little bit a heads up when you are assessing the use of a raw material, if it has a pro-inflammatory, anti-inflammatory, or neutral inflammatory potential, let's say. So again, it's not to stop using some of these ingredients. It's just that some of them will contribute towards inflammatory status. Then, as I said, we also, in this case, we had to kill the fish after the trial, and we collected the anterior intestine, and we measured a panel of 22 genes, which target several clusters of what we called of bioactivity. The oxidative stress, antimicrobial role of certain peptides, inflammation and immune response, and epithelium integrity, permeability. Of course, gene expression analysis can be very complicated with highly sophisticated biostatistical tools. Here what I am presenting is a very, very simplified version on how we exploit the results. But then all the genes in, I think for the oxidative status, it's a panel of 6 genes. This is a sort of an average of what they gave. And then again, we characterized, and I put it in the gray area is a little bit what we would consider as a natural biological variation. A bit up, a bit down, it's part of biology. But when it goes over the shaded area, it might mean something, or it might have a biological relevance. And we can see that the blood meal, for instance, really stands out on its oxidative potential, let's say. And of course, the blood meal we know, because of the high iron content of that ingredient, that generally tends to promote oxidative stress, let's say. Also, one important point that we saw when we assessed the inflammation and immune response genes was not only that some of them were higher than others or came out of what we would call the biological relevancy, but we also measured some of these genes, or the same genes, in the early stages of the trial, like 1 week after initiating the feeding. And even for, let's say, the krill meal, the fish meal and all that, the relative expression was much higher than what we found at day 34. So we got this impression, and then I think it's not that unlogic, which is the test diet itself, let's say the introduction of 30% of a raw material, is to a certain extent a challenging condition. And so, for instance, now what we are exploiting a little bit the data is not only as a snapshot of this moment after 30 days, but it's the reduction that we saw from week 1 until week 4. The delta of the reduction on the expression of the inflammation, because this can also be quite informative on how the role, because they all, if we consider one as the neutral line, they all seem like they are activating the immune system, and it's true, but sometimes what is important is the delta, the change. And here you have again, some nice information on the epithelium integrity with this is mostly focused on the tight junction proteins and criteria like this, genes like this, and we see again that some of the genes. So again, this is something that has to be put together with a multifactorial approach with other parameters, and this gives us an indication on the direction that a certain raw material might lead us. Then, coming out a little bit out of that salmon trial, it's another approach that we have been developing, and now it's already implemented, which is the ex vivo intestinal explant. It's a biological system to screen the functionality of ingredients and additives. In a simplistic way, again, what we do is that we have fish that are fed a standardized diets. We have then collect sections of the anterior intestine. We incubate them in a sort of a microplate well with the culture medium and with the test products that are supplemented. the cell tissue guarantees a viability of around 5 hours. It's for me to close. Well, I'm Portuguese, I don't understand.
At 1700. And we would like to thank all exhibitors and visitors for today. Welcome back again tomorrow at 10.
Okay. No, but this is really ending. So what we again do is we have a set of markers that are genomic in this case, and we can have an idea on how the products are working. I give you an example here. This is not salmon, this is sea bream, and we tested with different types of fish meal, and some of them even on purpose damaged, with damaged proteins or oxidized lipids. And again, you can see that there are possibilities of detecting changes. And today, what we see is that every product wants to be functional. I don't know any ingredient guy that doesn't come to me and says, my ingredient, besides being a protein source, it has to have something functional. So we have also worked on this, and for instance, now we have established what we call the dextran sodium sulfate model, the DSS model. Again, is something that is very used in rats, in other land-based animals, and especially to human nutrition, in which we initiate the trial by feeding the animals with the DSS, that compound that I told you, that induces a mild and standardized intestinal inflammatory status, and then we start feeding the various feeds, the control, and then with the additives or whatever. And so we are measuring the intestinal regenerative action of the test products, and this has been proven to be quite reliable. I give you here an example on how the results are done, but of course this integrates zootechnical performance, some of those markers that I showed you, histology of the intestine, and some molecular markers. So to conclude, these were examples of new tools that we are trying to implement to refine our knowledge about the raw materials. In association to the digestibility trials, we, as I showed you, non-invasive inflammatory markers are possible to measure, but of course analytica are still a bit critical. There is a high variability and high variation between species, so this is something that we are still validating, genomic markers, of course, but this has to be backed by robust databases and biostatistical models, otherwise it's very difficult to take a clear picture out of them. And then we are much more focused on developing specific models for assessing functionality, the ex vivo explants, which works very well on feed additives. In raw materials is a bit more doubtful. Interesting to screen, benchmark, and establish doses, the DSS model, and now we are working also on a skin wound healing model. But the challenge is to transform all this knowledge that we are now able to generate into practical decision-making tools. So thank you for your attention, and if you want to further discuss a little bit this, we are on stand A179. Thank you.